So the first thing I want to do with you guys, I want to review the test. Okay. If you guys have any questions for them, if you don't necessarily have any questions or qualms, concerns about this, we can kind of push through them really fast. And then after that, we'll start in this week's material. So, any questions right off the bat? Specifically, did you guys remember the questions you were struggling with, things like that? So, Zach. Okay. Okay. That's the one you're going to go for? Okay. Any other questions as far as like going through the math? Because if not, we'll just kind of go through it really quick, but if there's specific ones, we'll focus in on those. Yes. You should be able to go back because the test closes at midnight, and then I think I have it set so you can go back through later and review.
Okay, so you just can't review it
Yeah, you just can't review it while the test period's still open, but once it's closed, you should be able to go back and it'll show you exactly the answers and everything else. So, okay, let's make this a little bit bigger. Okay, so we're going to round 20.706 to the nearest 10. So where's our tens place? The 2. Let's see, let's change this. Good. So the 2, rounding it to the nearest 10, so we look at the next digit. Does it round up or stay the same? There's our answer, 20. Where's my next one? Okay, round the same number to the nearest 10th. Okay, so where's the 10th position? The 7. Is that going to round up or down? Stay the same? Stay the same, so we end up with 20.7. Good there? Write 85 hundredths as a decimal number. Well, there's the keyword hundredths. How many decimal places? Yes.
So I'm going back and reviewing my test, and the first question is 20.706.
Mm-hmm.
It says round to the nearest 10. It says the correct answer is 20. So with 7 should you round up?
The first one was tens. The second one was tenths.
Yeah, so but like right here, so there's 20.7 and round to the nearest 10. 7 is greater than 5, right?
Right, but you look at the next digit. So in this case, our number is 20.7. So we want to round to the nearest tenth. So we have the value we're looking for, and then we're going to look at the very next digit. And so then if that next digit is a 5 or higher, we round it up. It's a 0. Yeah. Yep. Don't worry, I've been there. And same with this. So hundredths. So we have the THS, which means it's less than 1. So our answer is 0.85. Do we have a oneths place? No. Okay, converting decimals to the fraction, or converting fractions into decimals. So we have 6 and 23 1,000ths. So that value is going to be 6 point what? 023. Because remember, tenths, hundredths, thousandths. We have 23 thousandths. Any questions? Okay, perform the indicated operation. This comes into order, simply order of operations. Okay, PIDMAs, parentheses, exponents, multiplication, division, addition, subtraction. So in this case, we have 14 minus 4 plus a negative 5. What's the first thing we probably should do? Yeah, do 14 minus 4, but convert this guy to just get rid of those extra symbols. So we have 14 minus 4 minus 5. Just, just to simplify it down. When we end up with this, we get a 14 minus 4 gives us 10. Minus 5 is 5. We could also do this, you could do 4 minus 5 is what? Negative 1. And then 4 minus a negative 1. I said we're going to go from left to right. Otherwise, you're going to get screwed up. Left to right using Piedmas. Okay? The answer is 5. Okay, now we come to another one. 6 minus 5 minus 4 times the quantity of 8 times the quantity of 4 plus 2 minus 4. Where do we start with this guy? Parentheses. So we start with a 4 plus 2. That becomes 6. Now the next step is 6 times 8, the next set of parentheses. And the thing with parentheses too is you start from the center and work out. So then we have 8 times 6, which is 48. Then the next step, times 4, which gives us 192. So then we've got 6 minus 5 minus 192 minus 4. Plug that into our calculator. Negative 195. Does that make sense? Okay, we want to express 1,000 in power of 10 form. So basically we want to express this number in some sort of a power of 10. Okay, how do we do that? Yeah, count the zeros. Okay, also remember that 1,000 is the same as times 10 to the 0. Okay, so if we're going to decrease this value, we're going to increase that value. So kind of remember that conversion back and forth. So this becomes 1 times 10 to the 3, because we're going to move 3 decimal places, make it smaller, so we have to increase our power of 10 by 3 places. Everybody good? Also, Kaylee was saying this earlier, what is this in terms of what prefix is it? Kilo. Okay, express a million. How are we going to do that? Or what's that answer? Huh? To the positive 6. To the negative 6 would be that. So yep, again, we're just moving this over, so we're making this number smaller. We're going to increase our power of 10, and it's going to go up 6 times. In engineering notation, what is 10 to the 6th? Meg. Okay, perform the indicated operation. Express your answers, right here's the kicker, in scientific notation, rounded to 3 decimal places. Okay, so first thing right off the bat, we can plug these into our calculator, we can get those values. But let's say we don't want to do that, we want to add these guys together. How are we going to do that? Well, first off, we have to remember we have to get them into the same base. That was the whole point of going up and down in these bases. So we can either increase this or decrease this down to a 4, or increase this one up to a 4. Doesn't matter either way. But let's say we'll increase this one up to a 4 to match. So this becomes 0.56 times 10 to the 4th plus 4.7 times 10 to the 4th. So this value becomes what? 10 to the 4th is going to go to the end, because now we're talking about the same units. So 0.47 plus 0.56 is 5.26 times 10 to the fourth. Now, that is the answer with this. Is this expressed in proper scientific notation? Yes, because it's a value of 1 to 9 times the power of 10. So our answer would be 5.26 times 10 to the fourth. Now let's just say we wanted to do this the other direction. We wanted to convert this one down to the third and add them together, because either way we could do it. So this is 5.6 times 10 to the third plus 47.0 times 10 to the third. We add them up together. 47 plus 5.6, 52.6 times 10 to the third. And then again, it says scientific notation, so we have to convert this down. So we have to make this value smaller. We increase that value. So both ways we end up getting the same answer. Make sense? Okay, perform the indicated operation and express your answer in a power of 10 form. When you're multiplying, what do you do if they have the same base? Add the exponents. So this becomes 10 to the 7th. Okay, perform the indicated operation, express your answer in scientific notation, rounded to 3 decimal places. So again, we could plug this into our calculator, or we could make this, condense this down to make it easier for ourselves. So which means we have to either express one of these two values in the same notation, or we could multiply them out. So right now they're both in times 10 to the 0. We could make one either, we could bring one up or one down to kind of make them easier to add or subtract. In this case, multiply them together. In this case, I would just throw it in my calculator. So 3,900 multiplied by 0.00173 gives me an answer of 6.747. No, I would keep it in 3 decimal places. So, then in this case, is that in proper scientific notation? Yes? You say no? Why not? Right, round it to 3 places. It'd be 10 to the 0. Yeah, so three places, yeah. Right. And 10 to the 0. We good there? Okay, more fractional math. When we're dividing and we have powers of the same base, we can do what? Subtract them. So in this case, we end up with 10 to the 2 minus 5, which is 10 to the negative third, which is going to make it really small, which is what we would expect. Because we're taking 100 and dividing it by 100,000. We're going to get a very small decimal. Okay? So this one we've got 10 to the negative second divided by 10 to the fifth. Again, we follow the same rules. 10 to the negative second minus 5 gives us 10 to the negative seventh. When you subtract negative numbers, you're going to go farther into the negative. Questions? Okay, now we got another one. We're going to multiply and then divide. So we're just combining all these steps together, making them more complicated. So we have 10 to the negative 2 times 10 to the fourth. We're going to add those together. That gives us 10 to the second on top, divided by 10 to the negative third on the bottom, which is going to give us a net of positive 5 because we have a negative subtracting a negative creates a positive. Or, sorry, third, that becomes to the 5th. Okay? Okay, when we're taking a power of 10 to another power, what's the step for this? Multiply them together. So in this case, we have 10 to the second times the negative 4th, which becomes to the negative 8. Because we just multiply those exponents together, and that gives us our new exponent. Okay, same with this. So basically, we have 10 to the negative 6 to the 1/2 power. Who remembers what the 1/2 power is the same as? Square root. So in this case, we're going to still multiply these together. So we have 10 to the negative 6, and that's multiplied by 1/2, comes up to negative 3. All right. So this one is, we're looking at, I don't know if anybody had problems for this one. So this one, we're just converting the numbers into their equivalencies. Okay? So we have, let's start with 1. Okay? What's the metric prefix for 1? Nothing. Okay, the symbol doesn't have one. Power of 10, 10 to the 0. Okay, 0.001. Which prefix? Milli. What's the symbol? Little m. And the power of 10 to the negative 3rd. I don't know if you guys caught that or not. They're all in order. I need to change that. I need to change that so it scatters them up a little bit. Oh, did it? Okay. I need to go change that question then. Not that, free points for you guys, but by the same token, you need to understand which one's which. Okay? What's a billion? Giga, symbol, big G, power of 10 to the 9th. That's actually funny that that's all in order like that. Good way to get 10 points. Do you want to go over any other of these? I got a feeling most everybody got this question right. Okay, so in this one we're going to be converting bases because we start with 76.3 milliamps, and our answer we want it in amps. So we're going from what power to what power? Negative 3 to 0. So we're going to be making the power of 10 larger, so the number we have to make smaller. So this will move over 3 decimal places, and this becomes 0.0763 amps. This is going to be common in stuff that we do all the time. Okay, 200 kilo ohms is how many ohms? 20,000. $75,000 hertz is how many kilohertz? 75K, which is what we would, what we're looking for there. Okay, given a resistor with the color code of brown, black, yellow, gold, we're finding our R value and then the min and max. Okay, so what is brown? 1. Black is how many? Yellow is? Gold is 5%. 100 kilo ohms plus or minus 5%. And then what's our range? How much up, how much down are we going to go? 5% of 10,000 is how much? 5,000. So it's going to go up 5,000? You're 5%? 5% is 5,000. Yep. Not 10, yeah. So we're good there. Any questions? Okay. Okay, given the resistor color code brown, red, red. 122 and gold is 5%. So what's the value? 1200 ohms, 1.2K. That's a very common value that you'll see. Okay, brown, gray, red, silver. 1800K, 1.8K. And then silver is 10%. Okay. Select the correct choice for these, basically the definitions for these words. An open is okay, a circuit that has no complete current path. Could be. I'll give you that. An unexpected high. So that's the difference. An open is when suddenly you have an unexpected high amount of resistance. Okay? An open circuit is a circuit that is intentionally designed to not have a connection, like our voltmeter. All those resistors are an open circuit until we select that range. An open is a failure mechanism. Okay, a closed circuit has a complete current path. And a short, unexpectedly low. So remember, an open is an unexpected high. An open circuit is a circuit designed that way to not have a current path. A short is an unexpected low. And a closed circuit has a complete loop for current to flow. Questions about that? Okay, for the next, 1, 2, 3, 4 questions, this is going to be our circuit. So the first one, we're given a voltage and a current. We're expected to find resistance in kilo ohms. So what's our formula for resistance? V over I, voltage over resistance, or over current, 2 divided by the 909.091 times 10. What is micro? -6. This is how many ohms of resistance? 2.2K. Yep, that can get into the rounding. 2.199 will still be acceptable. Okay, we have, again, another resistance problem. So voltage divided by current. So we have 71 volts and we have 4.438 milliamps. How much resistance do we have? Yeah, it just depends on where your calculator rounds it out at. Looks like these are all going to be about resistance. 10 volts is about current. I went through to make sure they had questions and everything. I didn't necessarily go through all the questions individually. Questions about these ones for solving for resistance. Okay, let's skip to the head. Okay, these next 4, we're going to be solving for current. So let's just solve for this first one right now. What is the formula for current? Okay, current is voltage divided by resistance. 62 ohms. So 99 volts and 62 ohms. 1.5 amps.
I put that in and put it wrong.
Did it?
Yeah.
Okay. 29. Okay, I'll go back and review. That's one reason we're going over these. If there are discrepancies, please let me know, and I can go back and I can manually regrade them and change grades. So. Yeah, if you feel, so that's the other thing too, is if you guys feel that the answers you got should be right, please come talk to me. Send them to me in an email. Said, hey, I missed this and this and this on the test. This is what I put. Show me your work, and I can go back and look at it. Because sometimes something doesn't carry over correctly in the question, or you know the question is got set up incorrectly. So on those, if you feel you got it, please let me know. Okay. And you put 1.5 versus 1.597?
Yeah, I just put 1.5.
That's what I was just thinking. Yeah, so the problem with that one is that one was just outside the tolerance.
Oh, okay.
1.5 versus 1.97 is about 6.1%. So it's like,
Just a smidge.
yeah, that's why I was saying always keep 3 decimal places.
Okay.
Yep, always keep 3 decimal places, and that'll help just maintain all those if there are questions for that. Okay, the next 3 questions, when they load, are going to be about voltage. So we have 909.091 microamps and 110 kiloohms. Gives us how much? What's the formula for voltage? I times R. So 909.091 micro times 110 kilo, 100. Okay. Let's get into these ones. Let's see, 37. So here you guys go. I'll show you the crap. So what are the steps for measuring voltage? So the correct answer, with the circuit operating, measure in parallel. That's the only way you can measure voltages. For one, it has to be operating. So right there we have with the circuit operating, measure in parallel. With the circuit operating, measure in series. Isolate the component and measure in parallel. That's not going to give you any voltage. Isolate the component and measure in series. Break the path and measure in parallel. Break the path and measure in series. So the correct answer is with the circuit operating, measure in parallel. Okay? So in this one, it's going to mix them up. So with the circuit operating, measure it in parallel. Okay, 38 was how do you measure current? What do we say? Break the path, measure in series, and with the circuit operating, measure in series. You're not isolating because you can't measure current if you don't have any power. Because if you isolate it, it's not connected to your voltage supply anymore. It's all by itself. So again, with the circuit operating, measure in series, and break the path to measure it in series. But it has to be in operation. So measure and break both in series. The next one, measuring resistance. So how are you supposed to measure resistance? With no power. So we know for sure that A and B, or D, sorry, are wrong. Because we're not when we're operating. Yes?
So then would you isolate the component and measure it in parallel or series? That's what I was
I'll put series because like I'm gonna buy on this one because like if you're gonna measure a resistor, it's just completing with the DMM on the resistor, so it's both like a series and a parallel.
It turns it into a series circuit is what it does. So this, like I said, this one I'll go back and change because this is what you're doing. You're isolating it and measuring it in series.
Okay,
So this one should be correct. But the main thing is here is you want to isolate it. See right here, this should be switched. For some reason, this one didn't transfer over correctly. So yes, you're going to isolate it and measure it in series. Because when you plug that, because that's how your meter works, is your meter is now supplying the voltage, and it's going to measure the current. It knows how much it has, and then it's going to subtract out basically your voltage drop or what your current shifts to. So for some reason, this one did not transfer over correctly, and I will get that one changed. Right. And the difference being on that one is you're breaking it and then you're putting it back together is the idea. Okay. And I will take care of that today after class. Okay. Any other questions about the test? So usually this is what we're going to do on the Mondays afterwards is we'll go through the review with the test. Some of the stuff we're not going to go through necessarily every single question unless I see kind of some trends on these. That's the cool thing is that I can see real quick, you know, which questions everybody's struggling with. Did I word something incorrectly? Is the question worded weird? And this was one that was brought to my attention already because it was across the board, there was weird answers. So it didn't look right to me. So that's one thing, like I said, I will go back. Sure, I have a note just to remind myself that I will go back and fix this one. All right. Any other questions about the test?
Just a random question.
Okay.
On this test, but it's like the bell curve are pretty accurate. Like look at what this grade and stuff was like.
Yes.